Our next speaker is Mr. Ross Palmer. He's going to speak about noise in high-rise buildings. Ross is principal and founding member of Palmer Acoustics. Acoustics in high-rise have been hardly addressed, and Ross is going to really shed a light on that. Thank you.
Well, good afternoon. I'm delighted and thrilled to be here. I think this is the most exciting forum to liaise with people, learn, network. I feel kind of daunted by the presentations I've seen, the quality of the PowerPoints, the quality of the people, and I've come here to speak about noise, and I kind of feel about this big. And what's noise? Many times it's not addressed. Many times it's said, well, it's something that's the last consideration. But I would like to put the idea forward that if you don't get the acoustics right, you have a building that is not functional. I had a friend of mine who's an acoustic consultant, very long experience, and he says, Ross, if you have an opera house and it has no acoustics, it's the same as a tin shed. The same applies to a building that we live in. If we get the acoustics wrong, we have amenity that people will not want to live with. Now, admittedly, there are a lot of buildings that, in third world countries, where people will live in buildings that effectively have no acoustics, no privacy, and a lot of noise. But that's not the standard the world we're going into. And we're going through an evolution now where quality is becoming a premium. I've been working in high-rise buildings now for probably 15 years. And 15 years ago, they didn't want to know what I had to say. There was no budget for it. It was given lip service. I was on team, but they didn't do it. They said there's no budget. Now they listen. They do it. And the reason they do it is the market is driving it. The expectations are there. People want it. If you have a building that has poor acoustics, it will get a bad name. In fact, it can show very clearly on the marketing. I find myself now dealing with the marketing people who are saying, how do we get the acoustics the top so we can get? In Australia now, we don't build to code. We build to above code. Now, what I'm illustrating here may be very simplistic and schematic, but it's the kind of things that you come up with in a building. There are multiple noise sources that affect the quality of the building. Not only are we talking about mechanical plant, external noise, we're talking about privacy, we're talking about waste pipes. We're talking about structures in the building that can vibrate. And by vibrate, they can affect not only one level below, they can affect multiple levels. I've seen chillers on a roof that affect almost 10, 13 levels down the building with noise. This is my playground, the Gold Coast, where I've done most of my work. And this is a showpiece of the number of buildings. Personally, I've been involved in probably 80% of the high-rise in the last probably 10 years. And it's been just a fascinating insight to be part of the teams and the projects, and an amazing place too. Brilliant place, lifestyle, waters. I hear other people at this conference talking about the pride of the places they come from. I'm proud of the places and the places, the work that we do. Brisbane and the CBD, again, we are getting now high-rise springing up. The high one in the middle there is going to be eclipsed fairly soon with another one fairly close. It's the nature of where we're going. High-rise is becoming a thing of the future. And we are now expected to provide quality. The problem with quality, it does cost money. You don't get it for free. There are some things that you can do that actually are good value for money, but it has to be a budget. And ironically, the one word I haven't heard spoken anywhere at this conference is budget. Money, cost. The bottom line seems to be, in what I do, how much is it going to cost? And many projects are on a tight budget, and one of the first things to be cut is the acoustics. To the frustration of the acoustic engineer who takes a pride in having a good project at the end. The issue of quality, legislation in Australia and a number of other countries is the bottom line. There's minimum requirements in terms of noise. But that is being superseded now by market forces, people expecting a lot better. And we never now build to the minimum codes. Quality buildings mean you've got less complaints, you've got happy buyers, you've got a marketing advantage, you've got less chance of litigation, and that's becoming a serious issue, particularly the acoustic engineer who worries about his PR. Some of the reasons we get into problems is we have developers who want to squeeze a large number of floors into a limited height. There's a ceiling at which the building cannot go beyond, so they will minimise the slabs, they will not put ceilings through, and it becomes cheap. And the consequence is you get transmission of noise. Thinner slabs, tighter budgets, market expectations, as the market goes up, they will judge a building more severely. And another thing is low-skilled labour, and this is an issue I find particularly in the work that we do throughout Southeast Asia and in the Middle East. They don't seem to understand that some of the acoustic performance is dependent on the quality of installation. Let's look at some of the specifics. Curtain walls, standard system, people seem to enjoy it, lots of glass, lots of vision. The problem with those is they hang over the end of a slab and noise will transmit vertically from one unit up to another unit. It's not easy to get a curtain wall system provide high levels of isolation. It's something to bear in mind. Double glazed systems, pretty standard, they work well. Impact noise is one of the most common issues that we deal with. Particularly in Queensland, people like hard floors, tiles, and the impact loads onto those can very easily be affected underneath. The biggest noise source, I'm told, is an 8-year-old boy. Kids playing on a hard floor, noise goes down. And people will often live in their apartment, this is my experience in Australia, they do not want to hear anything. So they will complain, and it becomes an issue. The treatment that we do is a resilient tile underlay, 6mm, 8mm thick. I have not seen them used in Thailand. I know some projects here use them, other projects here won't use them. There's still, I'm surprised at why some of the things I take for granted are not used universally throughout Southeast Asia and the Middle East. Party walls. And there was a time when we could get away with, by the time I mean 15 years ago, 110mm block wall was render. Those days are gone. All the party walls we deal with now are cavity systems, and the cavity system gives the performance. A solid wall on its own, unless it's something like 200mm precast, realistically doesn't have high performance. Plasterboard systems have become the most popular in Australia. Studs, plasterboard on each side. I cannot get my clients in Bangkok, Vietnam, and the Middle East here to actually put plasterboard wall systems in. They say the market doesn't like them. These are by far acoustically the best walls, but there is a perception that they do not provide security. You can hit them and they rattle. The fact of the matter is you can actually get through a brick wall faster than you get through a plasterboard wall if you have a big hammer. Cavity walls, better again. Separated studs, fiberglass in the middle. In fact, these are the standard walls we deal with. One that's come on the market recently that does actually have quite a lot of support is called a resilient stud. It's a single stud, but it provides vibration isolation and gives very good performance on about 170mm wall. And we also work with systems using aerated concrete and plasterboard and studs separated. This is the Asian red brick wall, which is the one that I find standard in Thailand. They love working with 70mm thick red brick. It does not work well, but that's what they insist on doing. It provides what we would say was the absolute minimum performance. So this whole area of education in terms of how to do things. If the red brick wall actually has 70mm, a 70mm air gap and 70mm and is rendered very well, it's not bad, along with a fiberglass infill. Waste pipes. I don't find waste pipes treated, particularly throughout Southeast Asia, where it's the norm that we wrap waste pipes, put them in a bulkhead and put plasterboard around them. And I'm showing there examples of wrapping systems. And again, more wrapping systems that by code we have to do. As a no-no, you don't actually grout your pipeworks into the structure that basically radiates noise. And the same again, you don't build your pipes into the wall. They radiate noise. Doors. Door seals are a good idea to provide privacy, an entrance door, balcony doors. Many times I don't see doors in buildings with door seals on them. Bear in mind, you cannot also retrofit a seal. Often these are fire-rated doors, and you cannot go and put a seal onto a fire-rated door. You will invalidate the fire rating. Pumps, mechanical plant has to be vibration isolated. This is a pump installation above a penthouse suite. There was a lot of noise, and it was simply a matter of putting isolating mounts and spring hangers and solve the problem. This is more specifically how it's done: inertia bases, springs, and flexible connections. We often find that we're putting buildings in the centre of the city, adjacent to other buildings, and we will get involved in noise from mechanical plant from other buildings. This can be quite a significant issue because you've got balconies looking straight onto a cooling tower, fans and the likes. Not an easy one with high-rise buildings. And here is a classic example of that. This is actually a view from a penthouse suite looking down on the roof of an adjacent building. There was quite a lot of noise from those cooling towers, which affected the amenity of the balconies. Large volume spaces. We get involved in looking at room acoustics, making sure there is not too much echo, making sure there is actually good speech intelligibility. Without that treatment, the space is virtually unusable for PA. Swimming pools, something that people don't think about, but if you put a swimming pool above a sensitive area, you will actually get noise as people jump in the pool, or swimming. And the standard treatment is to put them on springs. Not a cheap option. The preference is to keep the pool away from the sensitive area. If you're locating plant and equipment next to a sensitive area, the likes of a chiller, putting next to a penthouse suite, you actually have to create a room within a room, floating on concrete floors, floating walls, floating roof. It's a lot of detail, it's a lot of money, but that's the only way it can be done. We have performance tools, standard tools that we use all the time. We have ISO standards, American, Australian, British, Japanese, there's a whole string of them. We have performance criterias, different ways of looking at transmission loss, impact isolation, noise levels, reverberance, reverberation. We have the tools, we have the numbers, we have all the mechanisms to specify. We have standard understandings of what you will get if you have a performance rating. So we have all the engineering tools, we have the means of measure. It's just a matter of applying them. And in doing that, many times there are basic principles. First thing, you keep your noisy bits away from your quiet bits. You buy things that are quiet. You actually use speed control to slow things down at night maybe. You vibration isolate, you decouple, and you have heavy structures. Noise from waste pipes, we look at isolation systems under code which result in certain noise levels. When it comes to hydraulic systems, low pressures, low velocities, pipe wrapping, decoupling, flexible connectors, and, as we say, buy quiet. There are basic principles, there are standards, there's calculations we can do. Pipe isolation, decouple. It's not a big deal, but it makes a big difference. Mechanical systems, again, vibration isolate, buy quiet equipment, select on low velocities. Locate your chillers away from the penthouse. Use noise barriers. Now, this is kind of where I get involved. The acoustic engineer. We do documentation, detailing, specifications, inspections, testing. We're part of a team, and we're there to give what I call engineered predictability. We can tell the client what he's going to get at the end of the day. Our job is not to give silence, is to give him what's in his budget. And that we have the tools, we have the mechanisms, but unfortunately it doesn't seem to be taken seriously enough. Now, the other side of it is if you don't do that, and I've seen it very clearly. I had a job where I got called in to mediate between a hotel owner, a hotel operator, now this was a brand name operator, and the builder. The owner was very unhappy with the noise, and he had good reason to be. Now, he then complained to the operator. The operator went to the builder and says, "We told you we wanted 5-star. And the builder turned around and says, "We built to the documents." And I was called in to go and check it out. And yes, it was noisy. Yes, it was actually very poor quality. And yes, it was built to the documents. The documents were about half a page. And there's no dispute. At the end of the day, they had to live with a building that was nowhere near what the owner or the operator wanted. So without clear and precise acoustic documentation, there can be no clarity with regard to the completed project's acoustic amenity. Clear performance criteria and documentation allows predictability. It must be considered. Thank you.